So let's get started. So what we're going to talk about now for the next 40 minutes or so is a very brief refresher about XR. So I know many of you know about XR, but I'm just going to go through it very quickly. And then especially at the end, focusing a little bit on some AI and XR pieces. And then after this, as I said before, the next lecture is going to be given by Alison, and she's going to talk about integrating AI and XR together. So this is just to make sure we all know the basic fundamentals. So first of all, uh, when I was born, older than most of you in the room, when I was born, this was the state-of-the-art computer. This is the IBM 1401. This takes up the whole room, actually a small house size. If you go to the Computer Museum in Mountain View in Los Angeles, in California, you can see this working. So every month, every week they run it up, and it's a very large computer. In those days, this was about half the computers in the world. So IBM was selling a best-selling computer. Actually, they weren't selling it; they were renting it, and you had to pay $10,000 a month in the US to rent one of these computers in 1967. And $10,000 was the same as the price of a house. So, so here in Adelaide, average house price is about $700,000. You can imagine paying $700,000 a month to use a computer. So um, that was a lot. So, of course, since that time, computers have changed dramatically, and what you've seen is moving from room-size computers to the desk in the 80s, to the lap in the 90s, and then in the 2000s to the hand, and of course the phone. So the computer's really becoming is starting to disappear into our everyday lives. One of the long-term goals of computer interface people, though, is to try and make the computer interface go away as well. And traditionally, there's been a separation between the computer interface and the real world, so that the real digital worlds. You can see here somebody using a desktop computer, and there's the digital space on their screen, the physical world around them, and there's just been kind of physical separation between the two. Using windows and icons and menus to use the computer. So you can see on the top right-hand corner there, it shows this kind of artificial gap between the computer space in C and the real world in R. So one of the goals of computer interface designers is to make the interface go away, and there's really been three kind of efforts have been leading that. One is towards Internet of Things, VR, and then augmented interaction. And I'll talk about each of those very briefly. So first of all, Internet of Things. Many of you may have smart devices in your home. You may have an Alexa speaker, or you may have a smart thermostat, or some other smart devices. And in this case, the computers have been embedded invisibly into the real world. So you can see on the right-hand side there, all the little C's in the real world there. So the computer's gone away, and the only way we interact with the computer is through a speaker or a microphone or some other device in our real world. So this is one example of, I guess, called Internet of Things or ubiquitous computing, where they put computers throughout our infrastructure. More relevant for us, though, is of course virtual reality. So here in virtual reality, the idea is to immerse yourself in computer-generated content. So in the 3D environment, and so you're typically using head-mount displays, 3D graphics, and body tracking. And so you can see in the top right-hand corner there, the little blue person is now completely immersed in the computer space. So for him, the physical computer has disappeared because you can't see the real world anymore. And so the key features of virtual reality is really around immersion, interaction, and also your imagination. So I've got this short video to play here, and I'm not sure if the video you'll be able to hear it online or not, but if you can't, you'll have the YouTube link so you can play it anyway yourself later.
Virtual reality is simply the next logical step in computer interfaces, and this video outlines how user experiences are enhanced with three essential technologies. Stereoscopic 3D adds true depth perception by duplicating the image side by side to match natural eye separation and difference in perspective. Unlike 2D monitors and Cinema 3D, VR lets you accurately judge the size, shape and speed of elements in the world. As a result, objects and characters feel tangible, as if you could reach out and touch them. The combination of image distortion and the proximity of the display effectively wraps the picture around your eyes, providing you with a much larger field of view. The image fills your peripheral vision and enables a far greater spatial awareness and sense of presence within the world. Your eyes are freed from the confines of a small monitor so they can instinctively dart between items of interest, just as they would in real life. Low latency head tracking records your head movements so that both the visuals and the audio correspond to the direction you are looking. This extends your range of view to a full 360 degrees and lets you inspect the world or access information all around you. Head tracking grants you with the most visceral and intuitive way of perceiving a 3D space, making it easier than ever to explore digital worlds. In short, virtual reality will fully immerse you in a world so authentic that your brain will perceive it as real. And that is the true power of virtual reality.
So in that video, he talks about some of the characteristics of VR, in particular, 3D stereoscopic display, a wide field of view, and head tracking. And when these three things combine together, they provide this very compelling immersive experience. And really, the defining characteristics of VR is the sense of presence. So presence, it refers to the term of being the subjective experience of being in one place or environment, even when physically situated in others. So if you put with the VR headset on, you feel like you're in a spaceship, or you feel like you're in a castle, or you feel somewhere else, even though you're in the real world. And about 30 years ago, actually, David Zeltzer wrote this really interesting paper. He talked about how you can characterize interfaces in terms of their autonomy, their interaction, and their presence. So autonomy is the ability for you to react to things happening in the interface. Interaction is the ability for you to interact with the interface, and presence is the feeling that you're immersed inside of that. And he talked about having this cube. So you can see these three axes there, the interaction axis, the autonomous axis, and the presence axis. And so VR is at the far end of all of those three characteristics. So it provides you the ability to react to events happening in the space. You can interact with the space, and you feel present in the space. And of course, there are many types of VR. So here's an example of different types of VR experiences, ranging from rooms you stand inside, head-mount displays you wear, driving simulators where you operate vehicles, and stereoscopic screens where you stand in front of them as well. So that's one way that you can make the computer going away. And then another way is through augmented reality. So in augmented reality, the goal is to seamlessly blend images with the real world. So you can see a person there wearing an AI headset, and they're able to see these graphics come out of the speaker. So you can see on the top right-hand corner, the blue guy is interacting with the real world, but his interactions with the real world are mediated through the computer or through augmented reality. So here's an example of this. This is a This is an example of an augmented reality coloring experience. So you can color these McDonald's tray mats, and then when you use your phone, you look at the tray mat, and they come to life, and this little character pops up, and it takes the colors that you've added to the tray mat yourself. So it's a very nice example of using augmented reality for marketing in a mobile phone. And the key is that whatever color you add to that character, it takes those colors on board. And then you have these little mini games that are in the game there, so you can chase food around with the McDonald's character as well. And you'll see the character appears like it's really part of the real world around you. So that's the key elements of augmented reality. Ron Azuma wrote this paper in 1997. He talked about augmented reality have these really three key elements, combining real and virtual images, so you can see both at the same time. The virtual content is interactive in real time, and the content is registered in 3D, so the object appears fixed in space. And so with VR, the defining characteristic was presence, the feeling that you're in a space. With AR, the defining characteristic is what you might call object presence, and that the object feels like it's part of your real world. So you can see on the pictures there, on the left picture is the picture of the famous Christ statue from Rio de Janeiro. One of them is real and one of them is virtual, and it's hard to tell which is which, because they're both casting shadows and they both kind of look like they're real. And on the right hand side, you've got a tree that's placed in the real world, a virtual tree and a virtual elephant. So, you know, with augmented reality, the goal is to try and make these objects appear like they're really in the real world, using things like lighting and audio cues and occlusion and so forth. And then again, just like with VR, you've got many types of AR displays. So you can see here, there's a mobile AR with Snapchat. You can project onto cars with a spatial augmented reality. You've got AR on the windshield of your car. You've got smart glasses, and you've got immersive displays as well. So many different ways of experiencing it. There's potentially a distinction you can make between weak and strong AR. So weak AR is what you might experience on a mobile phone, where you have fairly imprecise tracking, no knowledge of the environment, and quite limited interactivity. Whereas strong AR is what happens in a headset, where you're wearing an AR display. You can have very accurate tracking. The content really appears part of the real world, and you can use your hand gestures to interact with it, so it's much richer as well. There's also a key distinction between AR and VR. So with VR, the design goal is to replace reality, and with AR, it's to enhance reality. So you can see in terms of the display, scene generation, display device, and the tracking, there's some interesting contrast. So in VR, you want to have very realistic scene generation, whereas with AR, even very minimal rendering is okay. So if I go back to this picture here of these smart glasses, even if we just got a little piece of text or arrows on the glasses, that is useful for us. With VR, the display device has to be very wide field of view and very immersive experience. With AR, you can have a non-immersive display and a quite small field of view if you want to as well. And then, so in both those cases, the scene generation and display device, virtual reality has very high requirements, and augmented reality can have quite low requirements. But it's the opposite for tracking. So with augmented reality, you want to be able to have objects that are precisely overlaid in the real world. So it needs to be able to track people's viewpoint very well. With virtual reality, if there's some low accuracy tracking or some latency in the tracking, it doesn't really matter because your entire experience is delayed or is low latency. So you have the opposite then as well. And what you can also do is you can arrange these interfaces, the ubiquitous computing and the augmented reality and virtual reality, on a continuum depending on how much they replace of your real world. So on the left-hand side, smart glasses or smart objects, I should say, they don't really replace anything of your real world. Like your Alexa doesn't have a display or anything like that. Whereas, sorry about that, just turn this off. On the right-hand side, with virtual reality, it replaces your real world entirely, and augmented reality is kind of in the middle. And this continuum is actually called Paul Milgram coined the term mixed reality, and so this is the mixed reality continuum. And he says the mixed reality is anywhere between the extrema of this virtual reality continuum, so between the real world and the virtual world. So that's what mixed reality is. And so when people start talking about mixed reality devices, they talk about things that exist between the real world and virtual world. One important thing is that the mixed reality continuum doesn't include pure VR on the right-hand side, but people now have coined the term extended reality, and extended reality does include those endpoints. So in this course, we talk about AI for extended reality. We're talking about using AI for AR and VR and everything in between those extend points there. So that's a little bit of the definitions. Now I want to talk briefly about technology. And there's really three key technologies that that are used to create XR experiences. That's the display, the input device, and the tracking. And you can see this from the technology requirements from the definitions. So before we talked about how AR combine real and virtual images. So in order to do that, you have to have some sort of display technology. And for AR to be interactive in real time, you have to have some sort of input and interaction technology. And for the virtual content to appear fixed in the real world, you need to be able to precisely track where the person is looking from. And so you need some sort of viewpoint tracking technology. So I'll talk about each of these briefly in the next few slides. Of course, these are very deep topics, so we could spend hours on each of those, but we won't today. So here's a basic AR VR display. You can see there's some electronics, the circuit board, some lenses, and when you put this on your head, on the right-hand side, you can see the virtual image appears at a virtual image plane that's set separately from the actual focal distance. So you have the images that physically might be on a display that's 1.5 or 2 inches from your face, but the virtual image itself will appear focused maybe 2 meters or 3 meters away from you. And so this is sometimes called the vergence accommodation effect, in that your eyes will rotate in to accommodate the images that are close to you. But because the images are set separately from each other, then you'll be focusing at a distance beyond that. So this is the basic hardware for a display. Of course, there are many different factors that go into AR and VR displays. Things like the focal length, the field of view, the resolution, the brightness, and there's also ergonomic factors like how heavy they are and how wearable they are. But head mount displays are only one type of display you can use to provide an XR experience. So you can also imagine you have displays in your hand. You might call them body attached displays. You also are able to project onto objects, so you can call that spatial displays. So you can arrange these displays in a taxonomy, which Oliver Bimber did in his book here about 20 years ago. He talks about how you can categorize displays, whether they're head attached, so a head mounted display or a head mounted projector, with the handheld, so you can hold a mobile phone in your hand, or you could hold a projector, or whether they're spatial, so you could have some image you look through. So this blue object is a real object. The purple line on the outside is the virtual image you're supposed to overlay on the real object. And you can see by looking through these different displays, you can achieve that. And actually, at the far left-hand side is a retinal display. So you could imagine you could be wearing contact lenses that provide a display as well. So that's displays. In terms of tracking, you can break tracking down into different types. There's active tracking systems that basically use electronics and external sensors to perform tracking. There are passive systems that use computer vision or inertial sensors, and then there's hybrid systems as well. So a GPS is an active tracker. You know, it uses external satellites and radio signals from your phone to track your location. For XR, one of the very popular methods of tracking is computer vision, and some of the old versions of AR used image-based markers. So you can see at the top there, these black and white markers. They're very easy to find on the camera image, and so you can perform very precise tracking. More recently, people are using markerless tracking. So if you have a picture you want to track from, you can find the visual features in the picture, and then most recently they're starting to track from the environment around you. So this video here shows an example of image-based tracking. You look at this picture here, and this robot appears, and you can overlay the robot onto the picture, and it appears like it's stuck on the picture. And the advantage of image-based tracking is when you put your hand over the picture, you can cover up parts of the picture and it still tracks just fine. On your phone, though, you have several sensors. So you have a camera on the phone, but you also have an inertial sensor like a compass and an IMU. And so you can use both of these together to provide very good tracking. This is what Apple does with their AR kit, and this is called visual inertial odometry. So the camera might take pictures at 30 times a second, so you can start using the image and the camera to track. But sometimes that camera will be blocked. And if you've got a compass in or an accelerometer in your phone, then you can record data from that at 1,000 times a second. So many times between the camera images, you can record the IMU data, and if the camera drops out, you can use that data instead for tracking. So this video here,
Hello, this is Marcus from VR.
I'm just going to
Since it's our
off here. So this shows using the Apple AR Kit tracking, and what you're going to see in this video is they will make an augmented reality view of a model aircraft. And so here's the plane here, and this is overlaid onto their interior of a house. So there's the 3D model of the plane. Now what the guy's going to do is start, well, first of all, he covers up the plane with the camera with his hand, and you can see the tracking works just fine, so you can still use the IMU. Now he's going to start walking around the house, and as he walks around, the camera starts getting more features in the house to track from, and it keeps on tracking even though he can't see the original images he was tracking off at the beginning. And it uses that compass to track in areas like that where it's very dark. So you see he keeps on walking around, and eventually he'll come back to the start point, and you'll see even though he's walked around quite a distance, the plane appears exactly where it was at the beginning. So Apple and Google have their own AR core system. They use these hybrid tracking, the visual inertial odometry, to perform very, very good, accurate tracking on their devices. There's also a difference between inside out and outside in tracking. So outside in tracking is where you've got sensors in the real world that are looking at you, and inside out is where you wear the sensors on your head. So one example of an outside in tracker is the Lighthouse from HTC Vive. This is where you put laser scanners in the real world, And on your VR headset, you have some photo sensors, and you can measure the position of the headset relative to the scanners. So this allows you to track people inside of a room, so in a 4x4 meter distance or something like that. But this is kind of old technology. So now people use more inside-out tracking. So a good example of that is the Oculus, or now the Meta Quest. And in the Quest, they have 4 cameras in the corner, and they look out into the real world, and they try and find visual features in the world to track as well. And this is really convenient because you don't have to wear it. You don't have to put anything in the real space to track. You can just easily put your headset on and start tracking right away. So the last thing I want to talk about is interaction and input. So this picture here shows a typical uh, input and output circle for or cycle for VR. So you can see on the left-hand side, we sense the real world using the various sensors we have, and then we perform some action that changes the real world. And so at VR, we basically replace a reality with virtual reality, and we do the same thing. So we can sense the virtual reality using a variety of output devices like displays and audio sensing, and then we can perform actions, and the actions can be captured and provided back into VR using input devices. And in VR and AR, there's many different ways of using input. One of the most popular is using handheld controllers, tracked handheld controllers. So with your Quest or with your AR display, you can have some handheld devices. Some people now are using gloves. This is an example from a New Zealand company called Stretch Sense that makes a VR glove, and it does very accurate hand tracking for hand input. And of course, you can have bare hand interaction as well. So with the new Quest 2 and 3, you can track your hands using the cameras on the Quest and perform natural hand input also. And this is really nice because it dramatically enhances your sense of presence, because you can feel you can get your real hands and reach out and interact with things. And then more recently, people are starting to use eye tracking on devices. So some of the more modern headsets will have eye tracking. And this is very nice because it performs a very natural way to have hands-free input. If any of you have used the Apple Vision Pro, then it has a very nice way of combining eyes and gestures together. And then what you'll see happening next, which is starting to appear in some commercial systems, is very rich sensor-enhanced head-mount displays. This is a display from a company called OpenBCI. This is the Glare display, and they have in the faceplate of the VR headset, they have a wide range of sensors for EMG for measuring face muscle movement, EEG for brain activity, EDA for heart rate, and PPG and so forth. And then across the top, they have EEG sensors as well for measuring brain activity. So this display is very expensive. The Galea display costs around 30,000 US dollars. But in the next 10 years, the cost will come down. So within 5 to 10 years' time, you'll have VR headsets and AR headsets that will have a wide range of physiological sensors in them. You can measure things like that, like cognitive load and activity as well. Then the last thing I want to mention is that you typically have this simulation loop where the user performs an action, the action is captured by various tracking systems, provides input into the application, and the application displays the output, and they keep doing it as well. One of the challenges with this, though, is there can be some delays in the system. So you could imagine if your tracking system is only recording tracking data every 3 times a second, or if you have a graphics hardware that is slow, then you can start having delays in the system. And this can also cause simulator sickness. So sometimes the sensory information coming from the VR system doesn't match your own vestibular balance system in your body. So your eyes will say, "Oh, I'm moving on a roller coaster," and your balance system will say, "No, I'm sitting in a chair." And that conflict causes simulator sickness. And about 20 to 30% of people who use VR have experienced motion sickness. Has anybody here had motion sickness in VR? Oh, about a third, yeah. So yeah, of course you can make it worse or better depending on how you design the VR environment, but it's quite common, especially if you spend long periods of time in VR. So it's one of the ongoing issues as well. And there's many causes of this. So one cause is due to latency. So if your virtual graphics are being updated very slowly, if the tracking is not very accurate, so the world is tilted or being or drifting, if you have a narrow field of view, if your refresh rate's low, if you have that conflict between vergence and accommodation, so that it causes eye strain, and if your eye separation is not correct, CSET. So there's a wide range of features that can cause simulator sickness. So that's the technology basics for VR. Let me touch briefly on a couple of applications. And so, of course, you can use VR and AR for many different types of applications. Especially applications that have a spatial element to it, and where you want to be able to blend the real and virtual world and have some connection to real world tasks. So one example is using augmented reality for enhancing hands busy tasks. So you can imagine in a warehouse, you have to perform a picking task where you've got to pick objects from the shelf, like if you're working at Amazon or something. And people now started using smart glasses and AR to enhance that. And it's a perfect use case for AR because it's a hands busy task. You've got to have your hands free all the time to be able to pick objects. And but you need to have spatial understanding of where those objects are. So let me just play the video here. So this is the getting ready for picking in the warehouse.
Welcome. The time is 6:47 a.m. There are pick requests available.
Begin.
Incoming pick request for customer 351. 22 items. Please confirm.
Confirmed.
Showing me the pick list. Go to aisle 17, shop 3.
Show item 1.
The size for item 1 is 30 by 25 by 5 and a weight of 0.5 kilogram. It's non-fragile. Pick 2.
Two okay. One okay.
So, and you get a guide where to go on the picture. So
Pick request confirmed.
you can input a picture.
Pick 3.
I'll stop that. So you can see how, because it's a very spatial task, using smart glasses and AR can really help with that. Another really popular example of using AR is for marketing. And this is an example of the Taco Head.
I love tacos. I like tacos.
This was
We love
released
tacos.
in
Tacos and burritos.
2016. And this is one of the first uses of Snapchat actually on a mobile phone. And in those days, Snap had the business model where you paid them to build the app for you. So this allowed you to look at your face and put a taco on your face. And Snap were paid $750,000 to do that. But it worked out really well for them because 225 million people tried this out on their phones. And this compares if you were to pay for a Super Bowl ad. Actually, now it's more expensive, but in those days it cost $5 million for a Super Bowl ad. So for a fraction of the cost of a Super Bowl ad, they were able to get far more people using the technology. Now, of course, if you want to build this for Snapchat now, you can do it for free because they've got their own tools as well. But this is a really nice example of how you can use a simple mobile AR to provide a compelling marketing experience. Here's a VR example. So VR is also very good for training. And so in this case, we're going to use VR for a crane simulator. So learning how to use a crane is very expensive and time consuming, and you don't want to make mistakes because you'll break a real crane. And also it's hard to get time on the crane. So what they've got here is they've got the same controls as a real crane, but in the VR headset, they see the view from the crane and they can practice on the real controls and learn how to use the crane. So you can see here. So you can see here it's using the real crane input, but in the VR headset it shows him the view from the crane. Now he can practice picking up and putting down containers, and in a very safe way. And of course they can practice things like how do you operate a crane in high winds, or what happens when one of the cables breaks, or whatever else like that. So this is a very, very good use case for VR because it provides that immersive sense of presence, it provides the same interaction you have in the real world, and it provides you the spatial actions as well. And actually here at UniSA, we've got, just the next building over from us, there we've got two flight simulators, which are very expensive full cockpit simulators. So you go inside this room and you sit inside an A320 cockpit, and then you can fly the plane, and then the windows are replaced by monitors that give you the view out of the plane window. So it's another example of using VR to support training. And one of my favorite use cases is for collaboration. So, you can imagine many examples where you're trying to do a task and it's very complicated and you get stuck and you need a remote person to come and help you. So using AR, you can call a person and have them come and appear in your real world, and they can annotate your real world and help you complete a task. So in this video here, you'll see a person.
No matter where you work or what you do, collaboration is the key to success. When challenges arise, you need the right people with the right expertise. But bringing people together isn't always easy, and travel is not always an option. With Microsoft Remote Assist, help is always a moment away. With a window into your world, backed by enterprise-level security, your team can collaborate with shared perspective, anytime, anywhere.
Bonjour, Amy. How can I help you?
We're having some issues with our machine in C5. I could really use your help again.
We just updated the manual for these.
Great.
This looks like an electrical issue.
I've never seen that before. Have you?
I think the Osaka plant had the same problem. Haruto's an expert on this.
Oh yeah. Let's bring him into the call.
Hey there.
Hey, Haruto.
What's going on?
Well, we're having some issues here. Do you think it's this component?
Our issue was the charging relay.
Okay. I'll try that.
Can you try this?
Okay. That's a problem right there.
Even though you might be a world apart, you can solve problems together.
That worked.
Used to be good to go now.
Great. Thanks for the help, you two.
See ya.
By bringing digital content and mixed reality and
So you can see in that case, they use an AR display. She was trying to fix this electrical problem, and she was able to call the one lady who could bring in, and then the lady was able to show her some just documentation appearing over the real world. Then they called in the Japanese man, and he was able to annotate and draw on the real world and show how to solve the problem. So it's a very natural way of being able to do remote collaboration. And then another important area is the medical space. So we've got the ability to image inside the body now, and using AR, we can now superimpose that imagery back into the real body as well. So it makes it more natural to understand rather than having the person look at the monitor separate. So you see in this video here, this is an example of taking ultrasound information and superimposing it back into the body. Oh, sorry, CT scan information. So a person's wearing this video see-through AR display.
Schaut wirklich gut aus. Sehr schön, dein Fuß.
They can then look at the patient's leg, and then in the video see-through display, they can see the CT image appearing as well. So this is the image of the person's ankle, and you can see how they superimpose it onto the real ankle. And by using a smart volumetric rendering, they can create the illusion that the bone is actually really inside the ankle. So it dramatically helps the medical surgeon understand what's going on. And then you can take arbitrary slice view, so you can slice through the data here as well. And so they can now say where they want to have the slices being taken from. That's a very nice example of using XR to help do situated visualization. So take information and visualize it back inside the body. And then finally, of course, there's lots of examples of using gaming. And this video here is one of the first examples of a collaborative mobile augmented reality game where you can play together. But there are many, many examples in VR and AR of gaming as well. So you can see the video here.
Let's finish this.
Here and now. No. Not here. Here. But where? I don't see anything. Oh, really? Look again. Oh! Hey, you set me up. I'm gonna knock your block off.
Basically, I was walking soccer games from the car, and then I a robot, but now you can play an augmented reality on a mobile.
What is this? It's Mattel. Of course.
So, but there are many, many examples of games as well. So the last thing I want to talk about is using AI for XR, and I'll just go through this briefly because we'll have a lot more lectures on this after with Alison and others today. So there are a range of ways you can use AI and XR around using content creation, prototyping, improving user experience, and using it for data analysis and insights into what's happening. So for example, with content creation, there are many tools, Gen AI tools you can use to create assets for AR and VR experiences, for 2D assets using Midjourney or DALL-E or 360 images like Blockade Labs or Stable Diffusion. One of the new areas is 3D models, so you can use text to make 3D models, audio and video as well. So here's one example. This is from a Tripo. So you can see I typed this prompt, a cute troll carrying a giant club, and then about 30 seconds later, it created this 3D model for me like that. So once you've got the model, you can then easily bring it into VR as well. So it's a very fast assets generation. You can also use pictures as well. So this is Hyper 3D from Rodin. I took this picture of a troll character, and then I brought it online into Hyper 3D, and then it generated a 3D model of that character right away as well. So this really dramatically changes the asset creation procedure. In the old days, it used to take you many, many hours to create VR content, and now you can just create that same content in a matter of a few seconds using AI tools. Also more complicated environments as well. So you can create whole procedural generated environments. So if you use Minecraft, for example, in Minecraft, all the landscapes and objects are all created procedurally, and there's the famous game No Man's Skies that has billions of stars in the game, and they automatically generate this content procedurally for you as well. So you don't have to, as a content developer, you don't have to build anything. And there are some tools you can use to make assets better. So Converse.ai, on the left-hand side, you can see a 3D model of a shoe. It's 48,000 polygons. And then they run it through Converse AI, and they produce the same shoe on the right-hand side, which is now 2,800 polygons, so a 20th or 18th of the size, but it still looks visually the same. So once you've got some content, you can improve it as well. So there's a lot of interesting applications you can use around AI in the content space. You can also use AI for prototyping. So if you want to build XR experiences, you can use AI in the development process. So AI can help you with interface design. It can add automatic interactions and behaviors. It can also help with with feedback as well. So for example, I use Gemini here to ask for some help around building an AR interface that uses gaze and gesture. So I had this prompt. I'm building an AR interface for head-mount display that uses gaze and gesture. What are 4 ways that gaze and gesture can be used? And then it spit out at the bottom different ways you could use gaze and gesture. And then I said which is most efficient and why, and it said which was the best. And then I said how would I build this in Unity for a Quest Pro display, and it gave us examples. And then it gave me these implementation steps. So if I can't even program, I can go to use AI, I can ask for advice, it tells me what I should be doing, and then it gives me step-by-step instructions with Unity how to build that. So it's a very useful tool. AI can also be used to enhance the user experience. So it can be used to build XR systems that respond to your behavior, create more natural user interfaces, add intelligent characters, and also create personalized VR experience training. So, for example, people are starting now to use gaze and gesture together, and you can use AI to recognize the gesture and gaze input and then fuse them together into a more natural interaction. So you can see on the right hand side, the person saying, put that green chair near this table. And you can understand what the person's saying by looking at where they're pointing. And so that fusion of gesture and speech together using AI can create a very natural interface. You can also start adding characters to VR and AR using AI to drive the characters, and this means you can then have a free conversation with them as well. And there are many companies now producing tools. One of the more popular is one called Conv AI. So Conv AI lets you create a character you can drop into VR, and it's very easy to do. So on the right hand side you can see a text box. In this one here you have to type your character profile. So you say, well, my character is, you know, maybe a waitress, and she's going to want to ask me to order food, and here's the special items, and this is some other information about her. And then you drop that into Conv AI, and it creates a character that has that conversation automatically. And they can easily create Unity or other export packages that makes it very easy to add to your VR system. So here's an example of why is the audio not working? Huh, something's wrong with the audio. Okay. Oh, that's lame. Well, you can read the subtitles, but so NVIDIA worked with Conv AI to produce this very, very nice demo, and for some reason the audio is not working on my computer. But in this demo, you can see this is a futuristic bar. When you go into the bar, you can start talking to this character in real time, and you'll see the subtitles there, but it's a bit better if you can hear the audio. And so the character is going to start talking about he says, how are you? And he says, well, not so good. And he starts talking about how he's worried about the crime around him. So in the game, they've created this motivation for the character around crime, and it starts having the interaction with you as well. So I think Tamer will talk more about Convey later today, but it's a very, very powerful way to add AI-driven characters to your VR and AR experiences. Then the last thing I want to talk about is data analysis and insights. So you can use AI also to get analysis of your behaviors in VR. So just the same way as you can use analytics on the web to measure people's web interactions, you can use AI to analyze data collected in user testing of XR prototypes, or you can use it for emotion detection while people are inside VR displays. So, for example, there's a company called Cognitive 3D, and what they do is they create a small plugin you can add to your VR or XR program, and it measures multi-sensory input. So it measures your eye tracking, your heart rate, your EEG, your body movement, and then it uses AI to process the data to create heat maps of people's interaction in VR. So you can see on the left-hand side some of the input being connected, on the right-hand side some of the heat maps being created. So here's a video of this working. And oh, this one's not also, that's really weird. Yeah, there's no sound on this, but I can give you the voiceover. So what Convoy AI does is it takes it's a Unity plugin, and inside Unity you can say what types of data sensors you want to measure. So here's a person interacting in VR, and those purple spots there are the hot spots where they want to look at. So it's really interested in where people are grabbing objects, interacting with them, and then it can create that heat map, and then it creates an analysis page for you there telling you how much people interact with objects. So you can imagine if you're doing a marketing application, for example, if you're building a model of a supermarket, it might be very important for you to know how often people look at certain objects on the supermarket shelves, and you can use Conv AI to measure that information and then process that all through AI as well. So that gives you a range of ideas about how you could use AI with XR, all the way from development to characters to content creation, and then to creating insights about people's behaviors in AI and XR as well. So that's pretty much what I wanted to say on the introduction slides. We've got a few minutes now before the next lecture starts at 11 o'clock. So does any of you have any questions about what I've been talking about today? And just to remind you, I will make all the slides available, and also the recording will make available as well. So you can go back and rewatch the videos and things like that. So does anybody have any questions in the room here, or does anybody online have any questions? Thank you for joining.